So that's just, a quick general overview of token policy. Monetary policy gives you an idea of what we're going to talk about, and then we can move into token policy. So what's token policy? Token policy is the design of how the tokens will be managed and governed. Very simple. It's the design of how it's managed and governed. When we look at token policy, we're looking at two areas. We're looking at monetary policy, which are things that we talked about just now, and now we're going to apply those foundations into your token design. And then we talk about valuation. So monetary policy, we'll be talking about supply level, interest rates, leverage on assets, which is similar to required reserve in a way. Or we talk about valuation, which is something that everyone likes to talk about. Your price level, your valuation of the ecosystem, how do you determine price level, how do you determine valuation, and stuff like that. So for this lesson, because these are two big topics on its own. For this lesson, we're only going to talk about monetary policy. Next lesson, we're going to talk about valuation. So some real world example of monetary policy and token policy. In the off-chain physical world, we've got the central bank. Central bank is the Mr. Big Boss bank that controls money, manages money. So in the US, we have the Federal Reserve. We call them the Fed. In UK, you've got the Bank of England. In Singapore, you've got the MAS, Monetary Authority of Singapore. So basically, how it's being governed is just a group of very, very smart people come together and they will do the analysis and they say, okay, this is how we should be, this is how we should do, this is the policies that will be implemented, and done. Centralized. On the other hand, in the on-chain crypto world, it's a bit more difficult because we have all these decentralized participants and all of them have a say in the matter. So the main decisions are in general embedded in code or can be embedded in code, and other decisions will be voted by the network. So it's decentralized. There's a level of centralization, which is, some basic general decisions embedded in code. And then you have other decisions that's voted by the network, which is decentralized. So what are the different examples? We have Bitcoin, BTC. It increases its supply mathematically. And the math is quite simple. The reward halves every 210,000 blocks. And so if you calculate it, it's about 21 million Bitcoins ever in existence. So that's one example. The main decision is embedded in code. It's embedded mathematically. It's this function that halves every 210,000 blocks. Another one is DAI. It's MakerDAO has two tokens. One of them is DAI, which is stable. It's more or less trying to peg to US dollar. One DAI is about $1 US, and it increases the supply because we give collaterals in Ethereum, in Ether. So it increases supplies with collaterals. And that decision is embedded in code, as in the smart contract will take ETH and give you DAI. You also have stuff like Bangkok. The Bangkok protocol increases the supply mathematically and with collaterals. So it takes both. It takes both the collaterals and a formula to determine the supply of your tokens, or the price of tokens as well. So these are some decisions that's embedded in code. For stuff that is voted by network in MakerDAO, the network gets to choose the saving the interest rates basically, or the stability fee, which is interest rates, and so that is voted by the network. So in the on-chain world, it's a bit decentralized. We have a level of centralization that's executed with codes and formulas and mathematics, and then the rest is decentralized, where it's voted by the network.